In this video lecture, we can see the topic support vector machine from the third unit of Artificial Intelligence and Machine Learning. Objectives are to understand about the concepts of support vector machine and to apply support vector machine algorithm for problems. Support vector machine or SVM is one of the most popular supervised learning algorithm which is used for classification as well as regression problems. The goal of SVM algorithm is to create the best line or decision boundary that can segregate n-dimensional space into classes so that we can easily put the new data point in the correct category in the future. This decision boundary is called as hyperplane. SVM chooses the extreme points or vectors that help in creating the hyperplane. These extreme cases are called as support vectors, and hence the algorithm is called a support vector machine. So in this diagram we can see the data points are segregated and we can found a line, best line that differentiate the two set of data points. Such best line is called as hyperplane. And there may be the parallel lines near to our hyperplane. Such parallel lines, only one parallel line may be taken as a positive hyperplane, and in the left side another one hyperplane can be taken as the negative hyperplane. And our positive hyperplane and the negative hyperplanes are used for the evaluation of more accurate our maximum margin hyperplane. We can see the example. Suppose we see a strange cat that also has some features of dogs. So if we want a model that can accurately identify whether it is a cat or dog, so such a model can be created by using the SVM algorithm. So first of all, we will train our model with lots of images of cats and dogs so that it can learn about the different features of cats and dogs, and then we test it with a strange creature. So a support vector creates a decision boundary between these two data, cat and dog, and choose extreme cases, that is support vectors. It will see the extreme case of cat and dog. On the basis of support vectors, it will classify it as a cat. Consider the below diagram. So dataset consists of the images of animals, and our model will learning model will be produced by the machine learning algorithm. And when it will take the new data, when the new data means image of one animal will be given to the algorithm, and this new data will be applied into the model created by the training, and based upon the support vector hyperplane, a new animal will be analyzed, and it will be categorized as a cat by identifying the most probable features that is matches with the features of the animal cat. The SVM may be of two types, linear SVM and non-linear SVM. Linear SVM is used for linearly separable data, which means if a dataset can be classified into two classes by using a single straight line. Non-linear data means dataset cannot be classified by using a straight line. Then such data are termed as non-linear data, and classifier used in this case are called as non-linear SVM classifier. So already we just seen the terms hyperplane. So it is a multiple lines or decision boundaries to segregate the classes in n-dimensional space. But we need to find out the best decision boundary that helps to classify the data points. This best boundary is called as hyperplane of SVM. The dimensions of the hyperplane depend on the features present in the dataset, which means if there are two features, then the hyperplane will be a straight line, and if there are three features, then the hyperplane will be a two-dimensional plane. We always create a hyperplane that has a maximum margin, which means the maximum distance between the data points. The data points support vectors. Support vectors are nothing but the data points or vectors that are the closest to the hyperplane and which affect the position of the hyperplane are termed as support vector. So in linear SVM, suppose we have a data set that has two tags, green and blue, and the data set has two features, x1 and x2. We want a classifier that can classify the pair x1 comma x2 of coordinates in either green or blue. So there are two coordinates x dimension and y dimension. So with the help of x coordinates and y coordinates, we can plot a point. There are two types of points are marked with the different colors, green and blue. So we are getting the points like this. So it is a 2D space. By using a straight line, we can easily separate these two classes, but there can be multiple straight lines that can separate these classes. So we have just drawn two straight lines, but there is the possibility of multiple straight lines that will separate the two groups of data. Hence, the SVM algorithm helps to find the best line or decision boundary called as hyperplane. It algorithm finds the closest points of the lines from both the classes. These closest data points are called as support vectors. The distance between the vector and the hyperplane is called as margin. The goal of SVM is to maximize its margin. The hyperplane with the maximum margin is called as optimal hyperplane. So in this diagram there is a hyperplanes, and the best hyperplane is called as optimal hyperplane. Other two parallel lines are called as, they are also the hyperplanes, and the points, data points nearer to the closest to the optimal hyperplane is, they are called as support vectors. In non-linear SVM, there we can separate it by, if the data are linearly arranged, we can separate it by straight line, but in case of non-linear data, we cannot draw a straight line. So in non-linear data, we need to consider one more direction, that is the third direction, z. It can be calculated as z equal to x square by y plus y square. By adding the third dimension, the sample space will become as like this. So the SVM will divide the data set into classes in the following way. Since we are in a 3D space, hence it is looking like a plane parallel to the axis. If we convert it in 2D space with z equal to 1, that it will become like this. Hence we get a circumference of radius. Our hyperplane will be the circle. So we get a circumference of radius 1 in case of non-linear data. Thank you.